So welcome to attaching a debugger to Unreal. What we're going to do in this video is exactly what I've said on the tin, and by the end of it, well, firstly the game will play, which will be good. We'll have found out what was wrong by using the debugger, and also we'll be doing a little bit of other logging in Blueprint, which you can see here. We'll be printing out some references just as another kind of form of debugging, temporary debugging. So this video is all about debugging. Let's dive in and do it. Okay, so let's just remind ourselves of the sorry state we're in. If we try and play our game, we get a hard crash of the editor. Now, normally when I get a crash like that, I'd say, well, Unreal does that sometimes, particularly when we change blueprints. So we reopen Unreal and we just run again and see if we still get another hard crash, because sometimes it does just do that. Let me just close Steam. Okay, so if I play, I'm getting another hard crash. So what on earth do you do about these? This is the topic of this video. You could potentially think about trying to write to an external log file, perhaps an external file, and then look at that log to see what happened. But I'm going to show you perhaps a better way, or an easy, quick way, and a very generally applicable way, which is to use the Visual Studio debugger. So what we're going to do is we're going to open up our instance of the Unreal editor, but not click play, because it's just going to die when we do that. So you go to the debug menu and then attach to process, and in Xcode or other IDEs it'll be a similar idea to this. So we look through our list of processes, and one of those would be the UE4 editor. That is our editor that's running down here at the moment. So we attach the debugger to the UE4 instance. Now that will automatically change your user interface a little bit, and it'll go ahead and load some windows and do some attaching in the background. We don't need to worry ourselves too much about exactly how that's working and what it's doing. But now it says ready, and we can go back to Unreal and click play. Now what's happened here is Unreal is still there, but it's just sitting ready to crash. And Visual Studio has intercepted this, and it says, look, exception thrown, read access violation. This was null pointer. So it was a null pointer issue. And then we can click break. Now what break will do is it stopped the execution of Unreal just before it's closed itself. We can't go back to it. It's not in a good state, but we can see some very useful information. So what it's showing is the tank aiming component on line 28. There's a little yellow arrow. It's saying this is the next statement that will be executed. So it's sitting here, and it's saying that this, now what is this? This is the tank aiming component, and you can see that from the type here, has a value of null. So that it's the tank aiming component pointer that has no value. Why not? Well, what called aim at? I think it was the tank that called aim at. So let's go and find that. If you have trouble, you can bring back your Solution Explorer. Go find your tank.cpp, and let's look at that code. Now that code is actually here. It's just under this menu. So what we're going to need to do to make this work is actually allow Unreal to finish crashing, because what Unreal has done is it's popped a window up in the foreground over the top of Visual Studio. We could move ourselves out the way to look at the tank. That's another option. But let's just let Unreal finish crashing, put it out of its misery. The way you do that is you click Continue in Visual Studio, pass exception onto the program being debugged. That's going to pass the exception back to Unreal, but it can't handle it. It doesn't like following null pointers. It just dies and bails out. So now we're left just in Visual Studio without Unreal running. That's fine for now. So let's look at the tank. What we used to do in the tank's constructor is that we would add a tank aiming component as a default subobject. We tried that architecture. We decided not to do it like that and to compose the tank in Blueprint, but we never actually replaced the finding of the tank aiming component. Now, we're not going to do that in this video. We are just going to focus on protecting this pointer before we try and use it. In fact, I'm going to get you to do that because I've talked enough. So protect the null pointer we've just found. Ensure the game still runs with that. And don't worry about setting that pointer yet, and don't worry that the aiming won't work, okay? So go ahead, pause the video, protect up that pointer, and I'll see you when you come back. Okay, so welcome back. This is a very standard thing that we do quite a lot. So aim at should be saying to itself, if not tank aiming component, then, and we do it all on one line just so that we keep it short and sharp, then return. We just are protecting the pointer there. Okay, so if you do that and then go back to the Unreal project, we're going to need to recompile our code, of course. And then once we do that, what I'm hoping will happen is that the game will run, and it will run in such a way that it doesn't aim because the aiming component pointer isn't set, but it at least runs. And that is the point of pointer protection. In fact, this shows you exactly the difference between not protecting your pointers and protecting them. It's the difference between a hard crash and just some functionality not quite working, which you can work with. So we play the game now, and you see no aiming is happening, but we are not crashing, which is awesome. Now, just to set us up for what's coming next, there are a couple of issues here. If you're the smart amongst you, will have noticed that here we have a bunch of warnings about trying to read trying to read properties. We'll come to this in the next couple of lectures. But also notice, if you're sharp, that the crosshair is red. Now, if we look in the UI over here, in the player UI blueprint, in the event graph, we said that reloading would be red. Okay, well, that's fine. But where we have declared in the tank aiming component header file, this enum, we said we wanted the default state to be aiming. Now, aiming should be amber. So what's going on? Why are we getting a red crosshair? Well, what's going on is the same thing that you are seeing reported in the console. It's all to do with when things are happening. It's to do with when this BP aiming component reference is actually set over in the player controller blueprint, and whether or not it's actually finding a reference. So in the spirit of debugging, which this video is all about, let's just briefly look at what this aiming component reference is set to. You can pull off it. You can say string to turn it into a string, like so. And then we can come off here and say print the string. Now, when are we going to print the string? Well, on the get. The get actually happens every frame, but we're not concerned about when that get happens because we've left it to the engine to worry about this execution flow. But we're saying every time we ask about the color and opacity of this crosshair, print out the value of the aiming component for me so that we can check it's not none. Okay, let's see what it actually is. Play. Now that print comes by default. You see it on the viewport there on the left-hand side in blue. And it will also be printed into the log. You can see the log getting bigger and bigger. If I scroll down the log, you'll see none, 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 none. So we're actually not getting a aiming component reference. So where was that set, the aiming component reference? We can take a look. It was set in the tank, under the tank player controller, here. And it was set where we get control tank, and then we try and set this aiming component. It's not happening. So the subject of the next video is going to be working out why that is not happening. But for now, we have made great progress. We're actually not going to set the tank aiming component pointer yet because we need to think very carefully about how we put our tank together, when we put our tank together, where we put our tank together, and what we're doing about aiming component references and building up the UI and what gets done where, more importantly, what gets done when. So that's what we're going to talk about next.